Charged particle model, one of our most crucial things to know about is how an object becomes charged. We've learned that means that an object has more electrons than protons, or possibly more protons than electrons. But how does it get to be that? Before we can learn about the different methods of charging an object, we must first learn about two different types of materials called conductors and insulators. Key difference is that in conductors, electrons are free to move around, whereas in insulators, electrons are bound to their nucleus and don't move readily from one place to another. Some examples of conductors would be metal or water or anything that we know electricity can travel easily through. Most objects, however, are insulators. Things like plastic and rubber and wood are all great examples of insulators. Now, there are some materials that don't fall into either category. Some materials aren't a conductor or an insulator. So there actually are two other categories called semiconductors and superconductors. You can guess from their name their meaning. Semiconductors would be something that conducts all right, but not extremely well. Common example of this would be silicon, which is what circuit boards are made out of. Another example or another category is something called a superconductor, something that conducts extremely well to the point where there is little resistance to the movement of electrons through it. Superconductors are something that happen at a very low temperature and is something that's currently researched today. Now that we know about the two different main categories of materials, conductors and insulators, we can learn about three methods of charging. The first method we're going to talk about is something called conduction. Conduction is a method of charging two conductors, and with conduction we'll have two conductors that'll be equally charged. Also, conduction requires contact between our two conductors. So basically what happens here with our two conductors, when we do conduction, one of those two conductors is initially charged. And when we connect those two conductors, when we touch them to each other, electrons will move from one to another so that the two objects have an equal charge. So in other words, if we have one object that has 4 extra electrons and another object that's neutral, when we touch them together, our objects will each have 2 of those extra electrons. And then we can separate them, and they'll both have 2 extra electrons. We could do the same thing with a positively charged initial object, and when that's the case, some of the electrons from our neutral object will travel into our positively charged object to give them both a positive charge. Conduction is the simplest method of charging. Another method of charging is something called induction. With induction, we're charging a conductor still, but this time we're using an oppositely charged object. You'll see what I mean by that in a moment. With induction, there's no contact between our initially charged object and our conductor that we wish to charge. So let's look at a scenario of how induction works. We start out with an initially charged object, negatively charged in this case, and a neutral object. Our conductor, this metal sphere, is on an insulated stand, which is important because we don't want it to be grounded just yet. I'm looking at diagram A here. When I bring that ebonite rod, which is negatively charged, near my metal sphere, the electrons in the metal sphere will repel to the other side of the sphere, leaving only the positive charges on the left-hand side, as you see here. Next step in induction is to ground your conductor. Remember that grounding means that we are providing a path that electrons could travel either to or from the ground. In this case, those electrons want to get as far away from my negatively charged rod as possible. So they'll travel through the grounding wire to the ground. Then the next crucial step is to remove the connection to the ground while my negative rod is still near my metal sphere. Once I've removed the connection to the ground, I can remove that negatively charged rod, and you'll see that I'm left with a positively charged conductor. I could use this exact same process with an initially positively charged rod. The only difference would be in that case that negative charges would be attracted to that positively charged rod, and that once I ground it, more negative charges would enter my metal sphere. Once I remove the ground, I'll be left with a negatively charged metal sphere. How much charge comes into my sphere is something that's dependent on content that's above and beyond what we will learn in this class. So don't worry about how much charge enters the sphere. Just know about what type of charge does and the process for which it does so. The final method of charging is charging by friction. And so as we're charging by friction, this is a method where we can charge an insulator. And as a matter of fact, it's the only method that we'll encounter for charging an insulator. In this method, we're using the heat from friction to remove electrons from one object and deposit them onto another object. Determining which object electrons are removed from requires knowledge of something called the triboelectric series. Here's an example of that. In this diagram here, you'll see 8 different materials. And you'll see that some are toward the negative end and some are toward the positive end. Basically, when I rub 2 of these together, whichever one is closer to the negative end will gain electrons, while the one closer to the positive end will lose electrons. So in class, we rubbed plastic with fur. You'll see that plastic is closer to the negative side. So the fur gave up its electrons to the plastic, making the plastic negative and the fur positive. Those are our methods of charging. In class, we'll practice those methods as well as learn exactly what happens when we charge objects using these